This is the second of 3 webinars to introduce the MoSSEC Business Object Model. This webinar covers the objects used for templates, methods and collaborative process management. It is assumed that the first webinar covering the basics has already been followed. The aim of the 3 webinars is to introduce the range of objects in the Business Object Model and how these objects are interlinked. Why is this understanding needed? It is for the MoSSEC-enabled capability owners to understand which objects they will use for the inputs and which for the outputs for their functionality. It's also for domain specialist capability owners to understand what objects exist and so can be exploited by their modelling and simulation tools. The webinars include extensive UML and SysML diagrams, so familiarity with these concepts would be an advantage. The webinars do not cover the justification for the business object model and also do not cover how to link the capabilities together with the MoSSEC services. This latter is covered in a subsequent webinar. This webinar has 3 main sections following the introduction. The first section, Methodology Management, covers templates, types and quality gate types. The second section on methods is all about inputs and outputs for those methods and data flow for those methods during an associative model network, and it also includes sensitivities on those inputs and outputs. The final section, Collaborative Process Management, talks about requests, work orders and planned and actual activities. Now for the introduction section. The MoSSEC Business Object Model was developed under Crescendo. It provides the structure for a distributed dataset, and that is the subject of this webinar series. The Business Object Model also defines the web services which are used to expose the distributed dataset. The Business Object Model is built on the ISO standards for 10303-233, which is Systems Engineering, and 10303-239, which is Product Lifecycle Support. The Business Object Model and documentation can be found at the location shown. First, download and unzip the file. If you want to use the business objects as a model, you will also need to download and unzip the SysML guide, which will explain how to set up the SysML tool and environment. If you just want to view the model, the original zip file includes an HTML viewer at the location shown. This works best using Internet Explorer, though other browsers can be used but with reduced functionality. The business object model is structured in packages. This webinar series is in 3 parts. The first part covers the basics, which includes the base objects, actors, study management and model management, requirements including V&V and decision capture. The second webinar covers templates including methods with inputs, outputs and data flow and process management. The third webinar covers breakdowns and interfaces, both of which are included in architectures. This is the descriptive documentation. Every time you see this book logo in the webinar, it will be referring to this documentation. The documentation location is shown. The documentation has an introduction section and then the main body of the documentation, which describes the business objects. This is followed by a section on web services, and finally there is a direct link to the HTML viewer for the business objects. The documentation can be navigated either by clicking on hyperlinks in the tree or in the main body of the text. Clicking on a business object model will open a panel of more information. This information includes the notes for that object, also includes the generalizations for that object and any associated notes. Scrolling down will then also provide the properties and association notes and any operations with their notes. First, a quick refresher on the models. Each business object is shown in a box like this. This includes the name of the object and then any properties that are interesting for the view being shown. Each property has a name and what is returned. And then also any operations that are interesting for the view. Generalizations of the objects are shown here. Some of these generalizations are abstract objects, which are shown in italics. Also, if the generalization is acting as an interface, these are shown in orange. There are several different types of relationships. The first one is a composite relationship, which is shown with a dark diamond. These are contained within the object, so they do not exist outside of the object and are always part of that object. Then there are shared associations. So this is where the object is referencing an external object. Each relationship has a name and a multiplicity for that type of relationship. Generalization relationships look like this with a triangle on the end. Now on to the first section of this webinar. We're going to be looking at methodology management, which covers collaborative modeling templates, model types, key value types, and quality gate types. There is a large section in the descriptive documentation on templates and instances. This explains the major objects in this package and then goes on to explain how the templates are used. There is also a section in the overview which introduces these objects. This is a section in the model on methodology management, and it shows the diagram that will be explained in the next slides. Incidentally, this diagram has a very similar layout to the Associative Model Network diagram that was explained in the first webinar. A model type is the definition of a model, and this is the image that you will see throughout this webinar series for model types. In common with all methodology objects, model types can have documentation that allow descriptions and examples or templates for that model type. These combine to form as detailed as needed a model definition for the instances of that model type. They can have property definitions. These will be associated values when the instances are created. For example, a typical property would be a numerical error. These are expected to be used for things like quality information. They're not expected to be used for key performance indicators such as weight. For this, a key value type will be used instead, and this can be included in the Associative Model Network. They can define the type of person who is allowed to authorize or approve this type of model. They can have publications. These are known as accessible model type constituents because publications are generally related to CAD models, and these could be, for example, a cell reference in an Excel model, or they could be a publication in a geometry model or a node number in an FE model. They are just identifiable objects, so they have names and descriptions, and it's expected that methods and tools who use this model know how to access the constituent from the model by just using that name. These are extensively covered in the third webinar. A model type can inherit from other model types. This allows the reuse of definition information when a specialization has been created. For example, you could have a mesh model and then a specialized to a thermal mesh model which inherits from the mesh model, and finally a wing thermal mesh model which can inherit from the thermal mesh and from the mesh model. The definition of a key value is the key value type. This includes the unit and the type for that key value. The key value type can also have documentation because it is a methodology object, and this can explain how to measure, for example, that key value type. The collaborative modelling template. This can be thought of as a template for an associative model network as described in the first webinar. This is the context for the associativity between the model types and the key value types. It too can have documentation explaining the intended use for that template. Collaborative modelling templates can be composed of other templates. This is useful where templates from several disciplines, teams or organisations are being combined together into a larger template. The disciplines, teams and organisations can retain control of their own templates, and then these can be consolidated into the combined template. A collaborative modelling template has operations to return the items in that template. There are two main operations. One is get the immediate items, and this is a list of all the model types and key value types that are associated to this collaborative template on its own. And the second one is get all items, and this returns all the model types and key value types that are associated to this collaborative modelling template and recursively through all the collaborative modelling templates that it is composed of. The information model allows a model type to be generated in different ways in different collaborative modelling templates. This is covered in more detail in the documentation. A typical use for this is in a load sizing loops process, where the same model type is initially derived from key values that are estimated sizes, and in subsequent iterations it's derived from models generated from previous iterations. Another typical example is where a model type can be generated in using lower order methods in a concept phase, and then higher order methods in a later part of the design process. This is a contrived example to illustrate the concepts. We have a torus surface model here, and in this particular collaborative modelling template it is derived from two circle models. One is the profile and one is the guide, and then they use a lofted method to generate the surface. The circle and the profile and the guide are both types of curve model type. In a second template, the same torus surface model type is generated from two key values. One is an inner radius and the other is the outer radius. This shows the example from the previous slide represented in business objects. The business object we use is the model type is derived from. This is very similar to the model instances derived from described in the first webinar, and where possible the layout of the diagram reflects the layout of the associative model net diagram in the first webinar. As with model instances derived from, model type is derived from is used rather than inputs to, because the owner of the model knows what inputs they need but do not necessarily know where their model is used. Model type is derived from is an object rather than a relationship because it needs to have other connections. The most significant of this is the context, and this tells you where this associativity is appropriate. There are two choices for the context. One is the collaborative modelling template, and the other is a methodology library, which is used in the case where the model type is always derived in the same way. The model type can be derived from three other types of objects. One is other model types, one is key value types, and the other one is accessible model type constituents. Key value types are the type definitions for key value instances, which are significant values that are to be exposed in the collaborative context. These are handled very similarly to the key value instances that we were shown in the first webinar. The same key value type can be extracted from different models in different collaborative modelling templates. For example, a weight can be extracted from a simple parametric geometry model in a concept phase, but in a detailed phase it can be from a weight estimation model. Key value instances are extracted from using an object. And this is because we need to provide the context for that key value type extraction. In this case, again, as with model types, they can be extracted in the context of a methodology library or in a collaborative modelling template. Key value types can be extracted from model types, or they can be extracted from accessible model type constituents. These are two examples shown and described in detail in the documentation. In this case, we've got one key value type, which is the beam deflection, and in this example it is extracted from a deflection workbook, which is an Excel spreadsheet, and that workbook then has some simple mass models and some second moment of area models, and these are part of a collaborative modelling template. The same key value type can then also be extracted from an FE deflection results model, and then this is in a second collaborative modelling template. Now we should look at quality gate types, and this is the image for a quality gate type. This is very similar to the quality gate instances that we were looking at in the first webinar. As with the model type, the type of person that can authorise and approve in that quality gate can be declared. The inputs to the quality gate are handled similarly to quality gate instance and model instances derived from, and so here we can see here's the quality gate input, and it's in the context of a collaborative modelling template, and the quality gate input type can be key value types and quality gate types and model instances, model types. The quality date type can control downstream execution of models, and again this is in a context. So here's the controlling in the context, and it can control model types downstream. That's the end of the section on methodology management. We'll now be looking at methods, resources, inputs and outputs to methods, the data flow in collaborative modelling templates and associative model networks, and finally sensitivities that can be associated to the inputs and outputs for those methods. Again, there is a lot of documentation on this. One is methods definition, and then the second page on methods and data flows. The previous section covered model types and key value types and their relationships in the context of the collaborative modelling template. This time we'll be looking at the methods and the inputs and outputs for those methods with the associated data flows. Scrolling from the collaborative modelling template diagram will bring you to the methods and resources diagram, which will be explained in the next slides. A method is a way to define how to generate the data for a model. A method is versionable and it can have associated documentation. This documentation can be as simple as a best practice guide, or it could be detailed step-by-step instructions to complete that method. Methods can have resources. These are needed if you need to trace what resources are used. You may need them if the method is an automatic type of method, or if it's not clear what is actually needed, or if resource planning is intended. This is actually an object rather than a straight relationship, because it may be you want to add a name to this resource, for example if there are several resources in different roles, or it could be that you want to add properties, for example how many licenses are needed or the type of licenses that are needed in this method. Methods types resources can be model types, for example for a template. There could be a type of person that's needed to run this model, but most commonly there will be tools, which is the actual software or other type of tool that might be needed to run this method. Scrolling from the collaborative modelling template diagram will bring you to the methods inputs outputs definition diagram, and this will be explained in the next slides. The outputs from a method are identified using the applicable method class. This points to the method and to the element that is the output or that the method can generate. It's called applicable method because originally it was a simple relationship called applicable method that went from the element to the method, i.e. the element owns the relationship. However, subsequently it was found that other information needed to be associated with the relationship, so it was converted to a class. However, the intention is still that the element owns the relationship, so the name was retained. The types of elements that it can point to are model types and quality gate types, which are not shown on this diagram. This shows the applicable method and the method with its inputs and outputs from the previous slide in the context of a collaborative modelling template. The preferred method object is used to indicate which method should be used in the context of the collaborative modelling template. This has the relationship applicable method, and it pointing to the applicable method, and the relationship context pointing to the context or the collaborative modelling template. If the same applicable method is preferred in more than one collaborative modelling template, then separate preferred method objects are created for each collaborative modelling template. Or one collaborative modelling template can be composed of another collaborative modelling template. A preferred method does not have to be specified. If there's only one applicable method, then the preferred method is superfluous. Or it could be that there is no opinion on which method should be used. Now to continue with our torus example. The first collaborative modelling template has method 1. This has two inputs, a profile and a guide. Both of these point to a curve model type. The second collaborative modelling template uses method 2. This uses a torus surface from dimensions and has two inputs, an inner, which points to a key value type of the inner radius, and an outer, which points to key value type of the outer radius. This is analogous to software definitions. For example, that you would define the method torus surface model method 1, which outputs torus surface model type, has an inputs of circle model type of guide and circle model type of profile, and the other one, method 2, also outputs torus surface model type and has two inputs, inner radius KVT, which is inner, and the other one, outer radius KVT type for the outer. A more realistic example could be, for example, a consolidated mesh method, which takes in a pylon mesh and a nacelle mesh and needs to distinguish which is which of the inboard and outboard connections on the two input meshes. Now we'll look at methods and inputs and outputs. So these are only needed if there are multiple inputs and it's not possible to determine which is which, for example in our simple torus example, or if quality domain information needs to be assigned, or if sensitivities need to be defined. The inputs can be applied directly to a method, so this is when the method has the same inputs no matter which outputs are generated. The inputs can also be assigned to an applicable method, so this is so that a method could have different inputs for generating different outputs. So the inputs for generic methods can be declared in this way. The types of inputs are allowed are key value types, accessible model type constituents, model types, and quality gate types, which are not shown. The method input assignment is an identifiable object. With this means you can give it a name. So in our torus example, this is how you distinguish between the profile and the guide. Method inputs assignments can also have properties. This enables quality information to be associated to the input for the method, so enables domains of, for example, validation, verification, validity, and intended use to be defined. There is a page in the documentation that covers this in much more detail. These are not intended for defining sensitivities, which are covered later in this webinar. This indicates the objects from the previous slide shown on the collaborative modelling template diagram. There is a worked example for method sensitivity in the descriptive documentation, which won't be covered in this webinar. If it is known how a method is sensitive to changes in its inputs, this can be captured by attaching a sensitivity to the different method input assignments. It's also possible to optionally add a sensitivity to indicate which output is impacted. Each sensitivity has a property value to define the sensitivity value. This property can be, for example, numerical if it's a known value, or it could be an enumeration if it's more of an indication of sensitivity, for example, high, low, normal, extreme. Because the properties have got definitions, the string enumerations can be agreed in the collaborative context. A sensitivity class can be classified to declare what type of sensitivity it is. For example, it could be a sensitivity to duration of the method or a sensitivity to propagation of change. Data flows are only needed if it is ambiguous which input is which. In our contrived example, we had a torus which had two inputs, a profile and curve, which were both of the same type. So the model type data flow is used originally to point to the method input assignment, which said it was a profile or a guide, and then it points to the model type is derived from to say which is which of those two model types that will be used to generate this method. Just a brief reminder of the example again, we have two collaborative modelling templates, both producing the same torus surface model type. The first one uses a method for lofting the surface with two inputs of profile and guide, which have both the same type. The second one uses a torus surface from dimensions method, which has two inputs, inner and outer, that use key value types. Then the analogy with Java, you're creating a method 1 which outputs a torus surface type which has these two inputs, guide and profile, which are both the same type. Now if we look at this using this method, again the analogy with Java, you have the torus surface method model type output. So method 1 in this example calls seal surface shape first and then seal cross section curve second. So this is the shape curve first, which it uses as the guide, and it has the cross section as the profile, producing this O-ring. If these are swapped around and you use the larger circle for the profile and the smaller one for the guide, you get a completely different output. So this is the rationale for why we need the data flows. As with the type definitions, data flows are only needed for the instances if it's ambiguous which is which. And again, it is very similar and it's laid out similarly to the collaborative modeling template diagram. So here is the data flow down the bottom, which points to the method input assignment, i.e. the profile or the guide for the method, and it has a link to the model instance derived from, which tells it which instance is which to use for that input for the method. The next section in this webinar talks about collaborative process management and covers briefly requests, work orders and planned and actual activities. There is a section in the descriptive documentation on collaborative process management which describes the objects and gives a simple example of the use. This is the section in the model on collaborative process management, and it shows the diagram that will be explained in the next slides. The first object in the collaborative process management is a request. All these objects are very closely aligned to the objects in the PLCS standard AP239. So a request is the identification of a request for something. A request has a name and a description for more explanation about what is requested. It can have a date for when it was requested, who requested it, and who was it requested of, i.e. the recipient and the requester. It points to what is being requested, so these are affected items, which can be many different types of objects. Note that it can point to more than one of these objects because it applies to 0 to 1 multiplicity. It can also point to what triggered the request, and it also has a status, so you can see whether it has been a new request, an accepted request, or a rejected request. The work order is the order to do something. The work order has a name and a description to explain more about what is ordered and also who ordered it. It applies to objects. There can be 0 or many of these, and it's the same type of objects that the request can apply to. Note, it doesn't have to point to anything because at the time of the request, the thing being requested may not yet exist. It can also point to more than one thing. It is in response to a request or many requests, and it can be something that triggers a request. It can have a status, and note this status can be combined with a study status to get a consolidated status for the whole section. The planned activity is the plan for doing something. Planned activities have names and descriptions of what to do. They can have a planned start date and end dates, and they also link to who it's assigned to, and this is an actor, so it can be an organization, team, person or tool. The subject of the planned activity is what it's to do. For example, this could be creating a new model type or a new template. It could be executing an associative model network, or it could be creating results data for a model instance, or it could be running a quality gate. It's controlled by a work order, and it also can be something that triggers a request. For example, I'm planning to do something, so request something else to be done. It has a status, and this status can be consolidated into the model instance status. It can also point to the method that is planned to be used and to the resources that are planned to be used, and again these can have properties and names. The actual activity is what happen to something. So actual meetings are specializations of these. It's very similar to planned activity, except that it points to the plan and it has probably has more options on the status. These are the objects that can be subjects to planned and actual activities. So that's the conclusion of the second webinar. We covered the methodology management, which had templates and model types and quality gates. We had a brief look at some program management areas for the data flows, and we also looked at some collaborative process management areas. The third webinar is looking at breakdowns and components and their usage. It's also looking at interfaces with their connections and ports, and finally looking at architectures which extensively use both breakdowns and interfaces.